There is a moment, deeper than memory, when the whole universe is younger than a single heartbeat, younger than the time it takes light to cross a grain of sand. Everything that will ever exist is folded into a space smaller than this room, glowing at a temperature beyond any furnace, humming with an energy so even and so smooth that there is almost nothing to see. And yet, in that first sliver of a second, something may have happened. A faint unevenness in the glow, a place where the heat pressed a fraction more tightly than the heat beside it, and where the pressing was enough, a tiny region of the newborn cosmos may have squeezed itself shut, sealing away a knot of pure density behind a horizon of its own making. Not a star, not a sun that lived and died. Something far older than stars, a shadow that may have been born before the first light had anywhere to travel. These are the primordial black holes. If they exist at all, they are among the oldest things the universe could ever hold, and tonight you're simply going to rest beside the idea of them. Let that thought arrive without weight. You do not need to follow it closely, or hold any of it in place. There is nothing here to memorize, no thread you must keep from slipping. Let your eyes grow heavy and your shoulders lower themselves toward the bed. The facts will move past you like slow water, past a swimmer who has stopped swimming, content to simply float. Some of them will stay with you in the morning. Most will dissolve back into the dark, the way most dreams do, and that is exactly as it should be. What stays, stays. What drifts away was only ever passing through. For the next little while you have nothing to do but breathe and listen and sink. The smallest of these objects, if any were ever made, would be almost beyond imagining. Picture an asteroid, a lump of rock and iron the size of a small mountain, the kind that drifts silently between the planets. Now imagine all of that mass, every ton of it, pressed down and down until it fits inside a single atom. That is one possibility for a primordial black hole. A mountain's worth of weight hiding in a point smaller than the period at the end of a sentence. It would be invisible, it would be silent, it would pass through almost everything as though the everything were not there. And the strangest part is that nothing in the laws of physics forbids it. These objects are allowed, even if no one has yet proven a single one is real. The range of sizes they could span is so wide that it strains the language we have for size. From a possible weight lighter than a single raindrop, up through asteroids and moons and suns, all the way to thousands of suns gathered into one. A spread of some 20 or 30 steps, each step a multiplying by 10, stacked one upon another. No other single kind of object in all of astronomy is imagined across such an enormous reach. A star has its limits, top and bottom. A planet has its limits. But a primordial black hole, born not from any one process but from the raw squeezing of the early universe, could in principle be almost any size at all. To picture the full family of them is to picture nearly everything, from a mote to a multitude wearing the same dark coat. And whatever its size, each one would be a near-perfect sphere of shadow. A black hole's edge takes the simplest shape there is, smoothed by gravity into roundness, without mountain or valley or seam. The smallest would be a sphere too tiny to see, the largest, a sphere wider than a planet's orbit. But all of them, across that vast range, would share the same flawless curve, the most perfectly round surfaces the universe knows how to make, drawn in pure dark. The reason they could span such a vast range of sizes comes down to how they might have formed. A star can only collapse into a black hole if it is heavy enough to begin with. There is a floor beneath which a dying star simply cannot fall. But in the first instance after the beginning, there were no stars and no such floor. A black hole could form from whatever amount of energy happened to be squeezed into a small enough space. And so the possible masses stretch across an almost unthinkable spread, from lighter than a feather to heavier than 1,000 suns, all depending on how big the region was when it sealed itself away. The earlier the moment, the smaller and the lighter. The later the moment, the larger and the more massive. Time itself set the scale. Consider how gentle the difference had to be. The early universe was astonishingly smooth. If you could have looked at it, you would have seen almost perfect sameness in every direction, varying by only a few parts in 100,000. Those faint ripples are real. We can still read their shadow today, frozen into the oldest light in the sky. In most places, the ripples were far too slight to do anything but rock gently back and forth. But here and there, the theory goes, a ripple may have crested just high enough, a peak in the density a little taller than the rest, and that small excess was enough to begin the collapse. A whisper louder than the other whispers, and a black hole where there had been only warmth. There is a precise threshold to all this, a tipping point that physicists can name. For a region to collapse rather than simply disperse, its density had to exceed the surrounding average by a particular fraction. Not a little, but not enormously either, somewhere around a few tens of a part more. Below that line, gravity lost the contest to pressure, and the region relaxed back into the smooth sea. Above it, gravity won, and the region fell inward past the point of return. The whole existence of these objects hangs on which side of that delicate line a given ripple happened to fall, a knife's edge between dispersal and collapse written into the first instant. And right at that edge, something subtle happens that gives the family its spread of sizes. Ripples that barely cross the threshold collapse only part way, shedding most of their substance back into the surroundings and leaving behind a black hole far lighter than the region that made it. Ripples that cross it strongly form heavier ones, so the mass of each black hole depends, with exquisite sensitivity, on exactly how far over the line its ripple reached. A faint variation in the early sea becomes a wide variation in the masses that emerge, the gentlest differences in the beginning, amplified into the whole range of these dark and silent objects. There is something quietly reassuring in that. The thing that may have made these ancient objects was not violence, not an explosion, not a catastrophe. It was the faintest possible imbalance in an ocean of light, a difference so small it would take a universe to notice it. The idea has a long lineage. More than 50 years ago, two physicists working separately, Yakov Zeldovich in Moscow and Stephen Hawking in Cambridge, began to wonder what might have condensed out of that primordial fire. They were not describing anything they had seen. They were asking a question. If the early universe was lumpy enough, in even the smallest way, what would the lumps become? The answer they arrived at was black holes with no stars in their past. The name came later, but the wonder was there from the start, and it has never quite gone away. It is worth resting for a moment on how the idea has grown. When it was first imagined, it was little more than a curiosity, a footnote to the new science of the early universe. But over the decades, it has become one of the most studied ideas in cosmology, drawing in thousands of careful papers, threading through the great questions of dark matter and the first instant and the nature of gravity itself. An idea can have a life of its own, growing slowly across generations of patient thought, gathering meaning the way a riverbed gathers depth. This one began as a quiet question in two separate minds, and it has been quietly deepening ever since. The very word they reach for tells you something. Primordial, from the oldest root, meaning first of all, before anything else. These would be objects of the primordium, the very beginning, born in the opening sliver of time before the universe had any history to speak of. There is a kind of music in the name itself, a sense of something ancient and original, and it fits these objects perfectly. Not made by stars, not made by anything that came after, but by the first conditions themselves, in the first moment there ever was. What makes them different from the black holes you may already know is precisely that missing star. The familiar kind, the ones astronomers have actually found, are the corpses of giant suns that burned through their fuel and fell inward under their own weight. Each one is a kind of ending, the last chapter of something that lived. A primordial black hole would have no such story. It would never have been a star, never have shone, never have fused a single atom of hydrogen into helium. It would simply have been there, almost from the very first instant, a piece of darkness that skipped the stage of light entirely. and because they would have formed so early, they carry a strange intimacy with time. The smallest possible ones would have been born when the universe was perhaps a billionth of a trillionth of a trillionth of a second old, a span so brief that the word instant is far too slow for it. To form a black hole as heavy as our Sun in that early epoch, the region would have sealed shut within the first few hundred thousandths of a second. Larger ones, up toward the mass of a great star cluster, would have waited a little longer, perhaps a full second or two into the life of everything. In that sense, each primordial black hole, were it ever found, would be a small clock, its weight a direct record of exactly how young the cosmos was when it was made. None of this, it must be said, is settled. Not one primordial black hole has ever been confirmed. They remain a possibility, an elegant maybe, a door that physics has left standing open. Astronomers search for them with great care and have not yet caught one in the act of existing. But the search itself is a kind of beauty, a patient looking into the oldest dark for objects that may have been waiting there since before the first dawn. And as your breathing slows and the room grows soft around you, that is a fine thing to drift beside, a mystery that asks nothing of you, content to remain unsolved a little longer. To understand why so many of the smallest ones could never be found today, you have to meet one of the most surprising ideas in all of physics, that black holes are not entirely black. For most of a century they were thought to be perfect traps, pulling everything in and letting nothing out, not even light. Then, in the mid-1970s, Stephen Hawking discovered something stranger. At the very edge of a black hole, where the empty vacuum itself trembles with faint quantum activity, particles can slip away. The black hole glows, ever so faintly, with a radiation that now bears his name. It is not a beam or a flare. It is a whisper of warmth leaking from the edge of the dark, the way heat steals slowly from a cup left out in a cool room. The reason this can happen lies in a deep truth about empty space. It is never truly empty. Even in the most perfect vacuum, where not a single atom remains, the fabric of reality is always faintly trembling, pairs of particles flickering briefly into being and vanishing again before they can be caught. This restless shimmer is real, measured in laboratories, woven into the bones of the world, and at the very lip of a black hole, where the pull is steepest, one member of such a fleeting pair can fall inward, while the other escapes outward into the wider universe. To a distant watcher, the escaping particles look like a faint glow rising from the edge, light born from the trembling of the void itself, set free by the steepness of the dark. There is a beautiful subtlety in this that even Hawking found surprising at first. The energy carried away by the escaping glow has to come from somewhere, and it comes, in the end, from the black hole's own mass. The particle that fell back in carries a kind of negative balance, nudging the black hole's total a fraction lower. So the glow is not free. It is the black hole quietly spending itself, one flicker at a time, paying for its own light out of its own substance. The dark gives off radiance and grows lighter for the giving. The truly remarkable thing about this glow is which black holes shine the brightest. You might expect the largest to be the warmest, but it is exactly the reverse. The smaller a black hole, the hotter it burns. A giant one carrying the weight of a sun is colder than the empty space around it, its glow fainter than the faintest starlight, a temperature only a few billionths of a degree above the coldest cold there is. But a tiny primordial black hole, no heavier than a mountain, would be searing, its horizon hotter than the heart of a star. Smallness and heat bound together, so that the least of these objects would be the most radiant of all. It is the kind of inversion the universe seems to delight in, the tiniest thing burning the brightest, the faintest whisper carrying the most warmth. This backward relationship has a tidy form. Double the mass of a black hole, and you exactly halve its temperature. Halve the mass, and you double the heat. The two move in perfect opposition, locked together like the ends of a seesaw. So a black hole the weight of a great mountain might glow at a temperature of billions of degrees, while one the weight of the sun sits colder than the deepest winter of space. The same simple rule governs both, stretched across an unimaginable range. One law of warmth, holding for a mote and for a monster alike. And what pours out of the hottest ones is wonderfully even-handed. The glow of an evaporating black hole makes no distinction between matter and its mirror image, antimatter. It produces them in equal measure, particle and antiparticle streaming outward together in perfect balance. There is a fairness in it, a kind of cosmic symmetry, the dark giving back exactly as much of one as of the other, holding no preference, settling every account down to the last particle as it fades. And because they glow, they slowly fade. A black hole that gives off radiation must be giving up something in return, and what it gives up is itself. With every particle that escapes, the black hole grows a fraction lighter. As it grows lighter, it grows hotter. As it grows hotter, it glows faster and gives up mass faster still. It is the slowest of slow burns for almost all of its life, a candle that takes longer than the age of the universe to shrink even slightly, and then, at the very end, it quickens. The dwindling becomes a rush. After an almost endless patience, the last of it goes in a final, sudden flicker of light. How long this takes depends entirely on how heavy the black hole was to begin with, and the numbers are staggering in both directions. A black hole the weight of our sun would take so long to evaporate, something like 1,000 trillion years, that the present age of the universe is not even a rounding error beside it. It will still be here, almost untouched, long after the last star has died. But a small primordial black hole, born light, runs out far sooner. And one born with just the right modest weight, roughly the mass of a large asteroid or a small mountain, would have been evaporating for the entire history of the cosmos, and would be reaching its final flicker right about now. Somewhere, perhaps, in the long dark between the stars, such an ending may be happening as you breathe. A 14 billion year-long fading completing itself in silence, finishing its single sentence at last. That timing is one of the loveliest coincidences in the whole subject. The universe is roughly 14 billion years old. A primordial black hole with a mass of around 100 billion tons, about the weight of a modest mountain, has a lifetime of almost exactly that long. Which means that if any were born at that particular size, they would be expiring in our own era, not in some unimaginable past or future, but now, in the same stretch of time in which you happen to be alive and lying here in the dark. Of all the moments the universe could have chosen for these endings, it folded a few of them into the present. The arithmetic behind that lifetime is itself a marvel of imbalance. Because the rate of fading depends so steeply on the mass, a small difference in weight means an enormous difference in how long an object lasts. A black hole only a little heavier than that mountain mass would still have ages upon ages to go. A black hole only a little lighter would have vanished long before the Earth formed. The whole sweep of cosmic history, 14 billion years, fits into the gap between two masses that differ by hardly anything at all. Time is generous to the slightly heavier and merciless to the slightly lighter, and the line between them is astonishingly fine. It means too that the universe has been quietly clearing its own slate this entire time. From the very first moments, the lightest of these objects began winking out, the faintest and quickest first, then the next, and the next, an endless, slow procession of endings stretching across all of cosmic history. The lightweight ones went early, in the universe's infancy. The mountain-weight ones are finishing now. The heavier ones will not finish for ages beyond counting. A long, gentle thinning of the original crowd, each leaving exactly when its weight decreed, like guests departing a gathering one by one across an immensely long evening. When one of them finishes, the end is bright but brief. In its final second, a small black hole would release as much energy as a star pours out over millions of years, all in one place, all at once, yet so far away, almost certainly, that it would never trouble anything you love. it would appear as a sudden burst of high-energy light, gamma rays flooding outward, a tiny flare against the enormous dark. Astronomers have built instruments that watch the sky for exactly such flashes. They have seen many bursts of gamma rays from many causes, but none yet confirmed to be the death of a primordial black hole. Still, they keep watching, patient as lighthouse keepers, in case one of these ancient embers should choose tonight to wink out. There is a particular kind of telescope built almost for this purpose, arrays of mirrors on dark mountaintops that do not look at the gamma rays directly, but catch the faint blue shimmer those rays make when they strike the top of our atmosphere. A primordial black hole reaching its end would send down a shower of light that lasts only billionths of a second, and these telescopes can feel it, like fingertips reading a single raised dot on an endless page. They have not found one yet, but the looking continues, every clear and moonless night on quiet peaks around the world. It is worth knowing that the ending, even at its brightest, is far gentler than the word might suggest. When the idea was new, some imagined the final moment as a great explosion, a cosmic detonation. But the more careful picture is softer, a rising glow over the last fraction of a second, brightening as the object heats, releasing its remaining energy as light spread across a wide span of space and time. There is no shockwave to fear, no blast to flee. It is closer to a flare than a bomb, a brief brightening in the dark, fierce up close but harmless across the immense distances that would always separate it from anything you love. The early universe keeps its own quiet record of these endings too. In the first few minutes after the beginning, the cosmos forged its lightest elements, the hydrogen and helium that still make up almost everything you see in the night sky. The recipe was delicate, and the proportions came out just so. Now, if many small primordial black holes had been evaporating during those first minutes, their flood of escaping particles would have disturbed that delicate cooking, leaving the proportions of the light elements subtly wrong. Astronomers measure those proportions today in ancient unpolluted gas and find them beautifully consistent with the simple recipe, which tells them that evaporating black holes of certain masses must have been few. The composition of the oldest matter becomes one more gentle limit on the unseen, the universe's first kitchen quietly testifying to what was and was not there. The space between the stars where such an ending might occur is itself worth resting in for a moment. It is not truly empty, a few atoms drift through every handful of it, but it is emptier than any emptiness you could build on Earth, and colder and more still. Light crosses it for thousands of years without meeting anything at all. If a small primordial black hole were out there, drifting through that vast nothing, it would be the darkest thing in a place already dark, a pinprick of pure shadow moving through a silence so complete that its eventual flicker would be the loudest thing for light years in any direction. Now let the scale swing the other way, from the smallest to the largest, because the same idea reaches there too. At the heavy end, some primordial black holes might have been born already massive, hundreds or thousands of times the weight of the sun, sealed into being in the first second and never the remnant of any star. And these heavyweights may have done something extraordinary with all that time. They may have served as seeds. At the heart of nearly every large galaxy, including our own, there sits a supermassive black hole, a giant millions or billions of times heavier than the sun. How they grew so vast, so early in cosmic history, is one of the genuine puzzles in astronomy. Some of the largest have been found shining as quasars when the universe was less than 1 billion years old, already grown to monstrous size, far faster than the ordinary slow gathering of matter seems able to explain. One graceful possibility is that they did not start from nothing. They may have started from a primordial seed, a heavy black hole already present in the first second, around which a galaxy could later gather and grow. If that is true, then the colossal hearts of galaxies may carry at their very centres an ember from the first instant of time. It is a thought worth letting settle into you slowly. The brightest objects in the early universe, the quasars, blazing across billions of light years, may owe their existence to the darkest and oldest objects of all. Light grown up around a seed of primordial night. The puzzle these seeds might solve is sharper than it first sounds. Telescopes built to peer into the deep past have found fully grown giant black holes, each as heavy as billions of suns, shining when the universe was only a few 100 million years old, a mere infancy. By the ordinary reckoning, there simply was not enough time for an ordinary black hole to gather so much mass so quickly. Even feeding at the greatest possible rate, it should still have been small. The numbers do not quite add up, unless, that is, the giant did not start from nothing, unless it began already heavy, as a primordial seed laid down in the first second, with a long head start on all that growth. The very existence of those early giants may be a clue pointing back toward the first instant. There is an even subtler idea woven in here, gentle as a thread of smoke. A scattering of primordial black holes sprinkled unevenly through the young cosmos would have drawn matter toward themselves by gravity, becoming the first faint anchors around which gas could gather. In this picture, they would have helped the very first structures begin to form, hastening the assembly of the earliest galaxies. The great luminous web of the universe, the galaxies strung along their vast filaments like dew on a spider's thread, might owe some of its shape to a hidden framework of ancient dark seeds, present before there was any light at all to gather around them. The same ancient seeds, if they are real, might explain something gentler too. The quiet, ordinary fact that galaxies have centers at all. A galaxy is a slow whirlpool of hundreds of billions of stars, and most of them turn, over enormous spans of time, around a single dark heart. Were some of those hearts placed there at the very beginning, the structure of the night sky, every spiral arm, every glowing core you've ever seen in a photograph of the heavens, might trace back to a scattering of black holes that formed before there was anything to fall into them. This is the kind of idea that can, in time, be tested, which is part of its appeal. If the giant black holes at galactic centres grew from primordial seeds, then there ought to be a particular pattern in how their weights compare to the galaxies around them, and in how early the very first giants appear. Astronomers can look for that pattern as their telescopes reach deeper into the past. The seeds themselves may be forever hidden, swallowed long ago into the giants they became, but the shape of the giants today could still carry the faint signature of how they began. The beginning written into the present, waiting to be read. It is a beautiful thought to rest in, that the great bright pinwheels of the galaxies, which look so settled and eternal in their photographs, might each be turning around an ember from the first second of everything. The most majestic structures in the visible universe, perhaps organised from their first moments by the humblest and darkest of seeds. If it is true, then every time you've ever looked up at the soft band of the Milky Way, you are looking at a vast slow wheel that may turn, at its very centre, around something as old as time itself. For all their possible importance, these objects are extraordinarily hard to catch, and the chief difficulty is simply that they do not shine. A primordial black hole large enough to survive to the present day gives off almost no light of its own. It does not burn like a star. It does not glow like hot gas. It is detectable only by what it does to the things around it, and chiefly by what it does to light that passes nearby. This is where one of the most elegant search methods comes in, a method that turns the black hole's own gravity into a lens. Mass bends light. This is one of the deep truths of the universe, confirmed again and again since it was first measured during an eclipse more than a century ago. Anything with mass curves the space around it, and light travelling through that curved space follows the bend, the way a straight road appears to swerve when seen through old window glass. A black hole, being mass with almost no size, bends light sharply, and so astronomers watch the distant stars, millions of them at once, waiting for one to brighten in a particular telltale way. The effect is called micro-lensing, and it is as delicate as its name suggests. If a primordial black hole were to drift by pure chance, almost exactly between us and a far-off star, its gravity would focus that star's light toward us like a magnifying glass, and the star would appear to swell in brightness for a little while, hours or days or weeks, depending on the black hole's mass, before fading back to normal as the alignment slipped away. The star itself is untouched, only its light is bent. From here, it looks as though a distant sun took a slow breath of brightness and then let it go. To catch something so rare, you cannot watch one star and hope. You must watch millions, night after night, year after year, and wait for the universe to line one up for you. And this is exactly what several great surveys have done. Telescopes in Chile and in the high deserts have stared at the dense star fields of our galaxy's centre, and at the two small companion galaxies that hang in the southern sky, monitoring tens of millions of stars for the faint, brief swelling that a passing dark mass would cause. It is patient work, a kind of cosmic fishing, with the whole galaxy as the sea. One survey took an especially elegant approach, turning a single great telescope toward our neighbour galaxy in Andromeda for one long winter night, and in that night recording the light of nearly 100 million of its stars at once, again and again, hour after hour. The aim was to catch the very briefest possible brightenings, flickers lasting minutes rather than days, that the tiniest dark masses would produce. 100 million distant suns, watched all together through one patient night, in the hope that one of them might wink a little brighter as a shadow no heavier than a moon drifted across its face. It is among the most delicate measurements astronomers have ever attempted, and the near silence it found pressed the limits on these objects tighter still. The lensing also reaches across far greater distances to the brightest beacons in the sky. When the light of a distant quasar, billions of light years away, happens to pass through a galaxy on its way to us, that galaxy's gravity can split and focus the quasar's light, and within that focused light the smallest dark masses would leave their own fine, flickering signatures. So even the most luminous objects in all of creation, the blazing hearts of the early universe, become lanterns held up behind the dark, their light combed, as it arrives, for the faintest fingerprints of anything ancient and unseen drifting in between. What those surveys have found is, in its own way, just as interesting as a discovery would have been. They have seen micro-lensing events, many of them, but the pattern of how long the brightenings last has placed firm limits on how many black holes of certain masses can be hiding out there. Across a wide band of possible weights, from roughly the mass of the Moon up to many times the mass of the Sun, primordial black holes simply cannot be common enough to make up all the universe's unseen matter. If they were, we would have seen far more stars flicker than we do. The silence of the stars is itself a measurement. Where the night does not flicker, the dark masses are few. And yet, and this is the part that keeps the mystery alive, there remain windows the searchers cannot close. There is a particular range of very small masses around that of a large asteroid, where the lensing brightenings would be too brief and too subtle for current telescopes to catch reliably, and where the evaporation glow would be too faint to see. In that narrow band, primordial black holes could still, in principle, account for all of the dark matter in the universe, and no observation yet rules it out. A whole hidden population, each one no heavier than a mountain, could be drifting through every galaxy, through this one, perhaps through the very space around you, and we would not yet know. The window is small, but it is open. That unseen matter, the dark matter, deserves a gentle word of its own, because it is the great quiet companion to this entire story. When astronomers weigh the galaxies by how fast they spin, and weigh the great clusters of galaxies by how their gravity bends the light of everything behind them, they find far more mass than all the visible stars and gas can account for, about 5 times more. Something invisible is there, holding the galaxies together, and no one yet knows what it is made of. For decades, the leading guess has been some new kind of undiscovered particle. But primordial black holes offer a different and rather beautiful answer. Perhaps the missing mass is not a new particle at all, but simply black holes, ordinary gravity, made by the early universe, hiding in plain sight because they give off no light. There is something deeply restful in that possibility. It would mean the universe is not full of some exotic substance no one has ever touched, but full of a familiar thing, collapsed mass, the same gravity that holds you to your bed, simply present in a form too dark to see. The strangeness would not be in the ingredient, only in the hiding. The scale of that hidden mass is hard to hold in the mind, and worth a moment of wonder. For every glowing thing in the universe, every star, every cloud of shining gas, every galaxy you have ever seen pictured, there is roughly 5 times as much of the invisible something, weaving through and around it all. The bright cosmos we admire is the smaller part. The greater part is dark, silent and unaccounted for, a vast hidden scaffolding upon which the visible universe is merely the decoration. Whether or not primordial black holes turn out to be that scaffolding, the simple fact that most of the universe's substance is unseen is one of the great humbling truths of our time, and a strangely peaceful one, a reminder of how much remains gently beyond our knowing. There is a particular charm to the black hole answer that the particle answers lack. To make dark matter out of a new particle, you must propose something never yet detected, a stranger to all our experiments. But black holes are not strangers. We have seen them, heard them collide, photographed the light bending around them. To suppose the dark matter is made of them asks us to invent nothing new at all, only to accept that an old, familiar kind of object might be far more common and far quieter than we ever knew. It is the most conservative of the bold ideas, and there is a quiet elegance in that. To search the very smallest mass windows, astronomers have dreamed up methods even more delicate than ordinary lensing. One of them watches not for a star to brighten smoothly, but for its light to ripple, to break, very slightly, into the colours of a rainbow as it bends around an object so tiny that its lensing interferes with itself like light through a narrow slit. This is called femtolensing, and it would only reveal the faintest, lightest black holes, the ones near the size of an atom. It pushes at the edge of what telescopes can perceive, looking not for a swelling of light, but for the faint fingerprint left in light's own colours as it passes a shadow smaller than a grain of dust. The lanterns this method holds up are some of the most distant flashes in the sky, brief, brilliant bursts of high-energy light that erupt from the deep universe and then fade in seconds. As the light of such a burst travels billions of years toward us, a tiny black hole lying almost in its path would imprint a delicate comb-like pattern across the spread of its colours, a barcode written by gravity. Astronomers have examined many of these far-off flashes for exactly such a pattern, finding none yet that fits. Another window narrowed, another gentle no. But the very idea is a marvel, that a shadow smaller than an atom, drifting somewhere across the gulf of space, could leave its mark on a flash of light that set out before the Earth was born. The methods grow only more imaginative as the targets grow smaller. Some astronomers have wondered whether a tiny primordial black hole passing through an ordinary star would set the whole star faintly ringing, like a struck bell, leaving a subtle quiver in its light that sensitive instruments might one day detect. Others have asked whether one passing through a planet, or even through rock here at home, might leave some trace, however faint. None of these whispers has been caught, but each new idea is a fresh way of listening, a fresh ear turned toward the dark, and the sheer inventiveness of the search is, in its own right, a quiet wonder of the human mind. Another search looks closer to home, at the moon. Over billions of years, the lunar surface has gathered the scars of everything that struck it, preserved in airless stillness because there is no wind or rain to smooth them away. The idea is quietly clever. If tiny primordial black holes were common enough, a few might have struck the moon over its long history, punching through with a signature unlike any ordinary meteorite. The ancient, patient face of the moon becomes a record book, and so far its pages show no sign of such a visitor, which again tells us these tiny shadows must be rare. Even the silences of the solar system are speaking if you know how to listen. The hunt reaches into the hearts of dead stars as well. Scattered through every galaxy are neutron stars, the collapsed cores of exploded suns, each one a city-sized sphere so dense that a thimbleful would weigh as much as a mountain. They are remarkably good traps. The reasoning goes that if very small primordial black holes were drifting everywhere, a few would occasionally fall into a neutron star, sink to its centre, and slowly consume it from within. So the simple, stubborn existence of old neutron stars, the fact that they are still there, ticking away as they have for billions of years, places yet another limit on how many tiny black holes can be passing through the galaxy. The survival of the dead stars is, itself, a kind of evidence. A gentler version of the same logic looks at pairs of ordinary stars, two suns bound together, circling each other at a great distance across the emptiness, held by nothing but the faint thread of their mutual gravity. Such wide pairs are fragile things, easily disturbed. If heavy dark objects were common in the galaxy, they would pass near these loose couples again and again over billions of years, each pass giving a small gravitational tug until the pair was slowly jostled apart. Astronomers find many wide pairs still intact, still quietly orbiting after ages, and their survival, like that of the neutron stars, whispers that massive dark wanderers cannot be too plentiful. The enduring companionship of distant stars becomes a measurement of the emptiness around them. Whole small galaxies join the testimony as well. Out beyond the Milky Way drift dim little star cities, faint dwarf galaxies holding only a scattering of stars within a great cloud of dark matter. In some of them, the stars are gathered into a loose, delicate cluster at the centre, a clump so gently bound that any heavy dark objects passing through would, over time, stir it and puff it apart. The fact that such fragile clusters still hold together in galaxies thought to be nearly all dark matter suggests that whatever the dark matter is, it cannot be made of objects too heavy, or it would have unsettled them long ago. Even the most distant and dim of galaxies, then, quietly reports on the nature of the dark, simply by keeping its small stars gathered close. Step back for a breath from all this searching and consider the picture it paints. Across the sky, in a dozen patient ways, human beings are listening for objects that may not exist, reading their absence as carefully as they would read their presence. Flickering stars, scarred moons, surviving neutron stars, faint colours in bending light, each a different ear pressed to the same old question. Whether or not a single primordial black hole is ever found, there is a kind of grace in the effort, a species lying awake in its small corner of the cosmos, attentive to the faintest possible echo of the universe's first instant. The oldest light in the sky has something to add as well. When the universe was about 380,000 years old, it cooled enough for the primordial fog to clear, and the light that was set free in that moment is still arriving today, stretched and cooled into a faint microwave glow that fills the entire sky in every direction. It is called the cosmic microwave background, and it is the most ancient thing any eye or instrument has ever seen. Astronomers comb it for the faintest irregularities, and a population of primordial black holes, had they been numerous and heavy enough in the early times, would have left subtle marks in that glow, heating little pockets of gas or stirring the smoothness in measurable ways. The patterns in that oldest light, read with great care, become yet another way of weighing the unseen. There is a particular way they would have left their mark, and it is a tender one. A primordial black hole adrift in the young universe would have slowly drawn in the surrounding gas, and as that gas spiraled inward it would have heated and given off a faint radiance. Spread across the whole early cosmos, many such tiny radiances would have warmed the primordial gas just slightly, and that gentle warming would have smoothed the texture of the oldest light in a way astronomers can search for. By finding the texture undisturbed, they learn that heavy black holes feeding on gas must have been rare. It is a measurement made of warmth that never happened. The absence of a heating, read as carefully as a presence. Even the colours within that ancient light carry information. The earliest glow ought to have a particular pure spread of colours, the signature of perfect heat. But if energy had been poured into the young universe at certain early moments, say by black holes evaporating or feeding, it would have left the spread of colours faintly distorted, tinted away from that perfect form. Astronomers have measured the oldest light's colours with breathtaking precision and found them very nearly pure, which again limits how much these objects could have stirred the early cosmos. The exact shade of the universe's first light becomes a record of how quiet or how restless those first moments truly were. Even the first stars carry a clue. Before any galaxy had formed, the universe passed through a long, dark age, hundreds of millions of years of cooling gas and no light at all, until the first stars finally ignited and began to glow. Astronomers can probe that hidden epoch through the faint radio signal of primordial hydrogen, a soft note of a particular wavelength reaching us from across almost the entire history of the universe. If primordial black holes had been seeding heat into that gas, they would have altered the note in a detectable way. So even the cosmic dark age, the quietest chapter the universe ever had, is being questioned for the touch of these ancient objects. A great new telescope, flown out beyond the moon's distance to peer into the deepest past, has lately stirred this question afresh. Looking back toward the universe's first few 100 million years, it has found galaxies that seem more grown, more massive, and more numerous than the old reckoning expected so early. No one yet knows what this means, and there may be ordinary explanations, but some have wondered whether a hidden scaffolding of primordial black holes laid down in the first second might have helped those early galaxies assemble faster than they otherwise could. The freshest images of the deep cosmos, gathered by the most powerful eye humankind has ever built, have quietly breathed new life into one of its oldest ideas. There is a wonder simply in how the question keeps returning. For half a century, primordial black holes have risen and faded and risen again in the thoughts of physicists, each new instrument and each new puzzle giving the old idea another turn in the light. It is the mark of a truly deep question that it will not settle, that it keeps finding fresh reasons to be asked. These ancient shadows have proven to be exactly that kind of question, quietly outlasting every passing answer, always waiting at the edge of what we know. There is a special mass range where theory suggests primordial black holes might cluster, and the reason is a kind of cosmic exhale. In the first instance, as the universe cooled, it passed through moments where its very contents changed phase, where a sea of free quarks, the tiny building blocks inside every proton, suddenly bound themselves together into particles. At such a transition, the pressure holding the cosmos taut would have softened for a moment, the way a held breath softens when it's finally let go. And in that brief slackening, it would have become a little easier for a dense region to collapse. So if primordial black holes formed in any numbers, theory hints they might favour the mass that corresponds to that particular exhale, roughly the mass of the Sun. A whole population perhaps sharing a single weight, all marked by the same ancient moment when the universe loosened its grip. It is a strange and lovely thought that an object's mass could be a memory, that to weigh a black hole would be to read the temperature of the universe at the instant of its birth. Heavier ones remembering a cooler, later moment, lighter ones remembering an earlier, hotter one, each a frozen timestamp from the dawn. Density ripples are not the only way these objects might have come to be, and the alternatives are strange and beautiful in their own right. The early universe may have been threaded with cosmic strings, impossibly thin, immensely heavy filaments left over from the first instant, like cracks in a freezing pane of ice, stretched across the young cosmos. Where such a string crossed itself and pinched off a small loop, the loop could in principle have collapsed under its own enormous tension into a black hole, a knot in a thread of the early universe drawn tight until it sealed shut, another path to the same dark end, by way of the most delicate filaments imaginable. There is yet another path, gentler still to picture. In the first moments, the universe may have churned with bubbles, regions where its very nature was shifting from one state to another, expanding outward like bubbles in boiling water. Where two such bubbles met and their walls collided, the energy concentrated at the meeting could, in some pictures, have been enough to form a black hole. So a primordial black hole might be the lasting mark of a collision between two regions of the infant cosmos, each becoming something new, leaving a small sphere of dark where their edges touched. However they formed, by ripple, by string, or by bubble, each would be a relic of a universe still finding its shape. In the autumn of 2015, humankind heard a black hole for the first time. Two of them, far across the universe, had spiraled together and merged, and the collision sent a ripple through the fabric of space itself. A gravitational wave, a literal stretching and squeezing of distance, so faint that detecting it required measuring a change smaller than 1,000th, the width of a proton, across instruments kilometers long. When that ripple finally washed over the Earth, after travelling for more than 1 billion years, the detectors trembled, and we knew. Among everything those detectors have since heard, a few of the merging black holes have had masses that puzzled astronomers, masses that fit a little awkwardly into the story of dying stars. And so a quiet question was raised. Could some of these be primordial? Could the detectors, built to hear the deaths of stars, have also caught the echo of objects from the first second of time? The question remains open, as so many here do. Most of the mergers fit comfortably with ordinary stellar black holes, and no detection has been confirmed as primordial. But the possibility lingers in the data like a half-heard note. Each time the detectors ring, somewhere in the analysis there is a careful soul asking whether this one perhaps came from the very beginning, and that listening to is part of the long search. If primordial black holes were abundant in the early universe, they would have found one another. In the dense first moments, two of them passing close could have become bound into a pair, beginning an immensely slow dance around their shared centre. A dance that, across billions of years, would gradually tighten as the pair gave off faint ripples of gravity, until at last the two spiraled together. By this reckoning, some fraction of the mergers heard today might be the culmination of partnerships formed before the first star ever shone, a meeting in the universe's infancy, consummated only now, the closing note of a courtship 14 billion years long. There is a way to tell such ancient couples apart from the ordinary kind, and it lies in their spin. Black holes born from collapsing stars tend to inherit a certain turning, set whirling by the spin of the stars that made them. But a primordial black hole, formed from the smooth collapse of an early ripple rather than a rotating star, would likely be born barely turning at all, still and unspun. So when the detectors hear a merger of two black holes that scarcely spin, some listeners lean a little closer, wondering if the stillness itself might be a fingerprint of the first second. The absence of a whirl, read as a clue to the deepest past. Those same ripples might carry an even older signal. If primordial black holes truly formed from collapsing density peaks in the first instant, the violence of that formation, not violent to us, but immense on its own scale, would itself have sent gravitational waves outward, a faint hum from the moment of their making. That hum, stretched across nearly the entire age of the universe, would be almost impossibly low and faint by now, a background murmur woven into the silence of space. Astronomers are beginning to listen for exactly such a murmur, using a method as patient as any in all of science. That method turns the galaxy itself into an instrument. Scattered across the sky are pulsars, rapidly spinning neutron stars that sweep beams of radio light past the Earth with the regularity of the finest clocks ever found, some ticking hundreds of times a second, steadier than anything humans have built. If a low, slow gravitational wave were passing through our part of the galaxy, it would stretch and squeeze the space between us and each pulsar by the tiniest amount, nudging the arrival time of those ticks a few billionths of a second early or late. By watching many pulsars at once across decades, astronomers have begun to sense exactly this, a faint sky-wide hum of gravitational waves. And one of the possibilities being weighed is whether some of it could trace back to the formation of primordial black holes in the first moments of everything. Picture that for a moment as you lie still. Across thousands of light years, dozens of dead stars are spinning with inconceivable precision, and the faint stretching of space between them is being read like the trembling of a vast invisible web. And one of the things that Webb may be feeling is the distant echo of black holes being born when the universe was younger than a heartbeat. The oldest event, sensed through some of the steadiest clocks in creation. Only recently did that Webb first stir. After watching their pulsars for many long years, several teams of astronomers announced together that they had begun to sense a low murmur of gravitational waves washing through the entire galaxy. A slow, deep stretching of space. The longest waves ever felt. Most of it likely comes from the slow mergers of distant giant black holes. But woven into the possibilities is the gentler chance that some small part of the hum carries the echo of the first instant, the faint reverberation of primordial black holes forming long ago. To have felt that hum at all, after years of listening, is among the quietest triumphs in the history of science. A whole galaxy's worth of dead stars read together, beginning to reveal the softest sound there is. There is something almost tender in using the corpses of stars to listen for the birth of the universe. Each pulsar is the dense remnant of a sun that exploded ages ago, now spinning in the dark, sweeping its faint beam across the void with the steadiness of a perfect clock. Astronomers have gathered the most reliable of these scattered remnants into a single great instrument spanning the galaxy, and through them they strain to hear the deepest past. The dead stars keep time so faithfully that the trembling of space itself shows up as the slightest wandering in their rhythm, and in that wandering perhaps the faintest trace of the very beginning. There is a poetic symmetry in primordial black holes that is worth resting on. The ordinary black holes astronomers study are the universe growing old. They are what suns become at the end of their long lives, endings written into the fabric of time. But primordial black holes, if they exist, are the universe being born. They are beginnings, not endings. The same kind of object, a horizon, a piece of trapped space, sits at both ends of the cosmic story, once as the final word of a star and once as the very first word of everything. Darkness as a closing and darkness as an opening. The physics that governs these objects has a startling simplicity to it. A black hole, no matter how it formed, can be described almost completely by just a few numbers: its mass, its spin, and its electric charge. Everything else about whatever fell in to make it is erased behind the horizon, lost to the outside forever. Physicists have a saying for this strange plainness. A black hole has no hair. It means that two black holes of the same mass and spin are utterly identical, no matter that one was a giant star and the other a knot of light from the first second. A primordial black hole and a stellar one, if they weighed the same, could not be told apart by any feature. Their histories are smoothed completely away. The dark keeps no diary. That smoothing hides a deep accounting that physicists have learned to read in another way. Every black hole, it turns out, carries a measure of hidden disorder, an enormous tally of all the ways its insides could be arranged, scaling not with its volume, as you might expect, but with the area of its surface, the size of its horizon. The larger the horizon, the vaster this hidden tally. A giant black hole holds more concealed information than all the stars of a galaxy combined. A tiny primordial one holds correspondingly little. It is one of the strangest and most beautiful results in all of physics, that the secrets a black hole keeps are written not through its depths, but across its skin, like a message inscribed on the surface of a sphere. And because the surface scales with the mass in a particular way, the smallest black holes are the simplest things imaginable. A primordial black hole near the end of its life, shrunk down toward the tiniest sizes, would hold almost no hidden information at all. A few bits perhaps, where a giant holds uncountable trillions. It approaches a kind of perfect plainness, a near-empty page, the most featureless object the universe is capable of producing. There is a clean austerity in that, a stripping away of all complication that is restful simply to contemplate, a thing reduced almost to nothing but its own bare existence. That smoothness gives the smallest of them a peculiar gentleness at a distance. You might imagine that a black hole, even a tiny one, would be a thing of terrible danger, but gravity does not work that way. The pull of an object depends only on its mass and your distance from it, not on how small it is squeezed. A primordial black hole holding a mountain's weight would tug on you, from across a room, no harder than an actual mountain would, which is to say, not at all that you could feel. It is only in the final whisper of distance, almost touching the horizon, that its gravity becomes fierce. From any comfortable remove, the tiniest black hole is among the most harmless things imaginable, a speck of shadow, minding the small space it keeps. Consider just how small that horizon would be. The edge of a black hole, the boundary past which nothing returns, grows in proportion to its mass. One holding the weight of the sun has a horizon a few kilometers across, the size of a small city. But a primordial black hole carrying only a mountain's worth would have a horizon smaller than a single atom, smaller than a proton in fact, a sphere of perfect dark so tiny that the particles of ordinary matter are giants beside it. Matter could pass it by on every side and never find it. The most absolute boundary in all of physics, drawn smaller than the smallest things we know, and around even that impossibly small edge, light would do something beautiful. Near any black hole, the bending of space becomes so extreme that light can be caught into orbit, circling the darkness in a perfect ring before either falling in or escaping back out. This glowing circle, the photon ring, is the same phenomenon that gave us the first true images of black holes, those now famous portraits of a bright halo around a circle of night. A primordial black hole would wear the same crown, only inconceivably smaller, a ring of captured light too tiny ever to photograph, encircling a shadow narrower than an atom. The same physics that paints a halo around a giant would in miniature paint one around a moat. There is a tidiness in how that horizon grows that is deeply satisfying. The size of a black hole's edge increases in exact simple step with its mass. Double the weight, and the horizon doubles in width. Multiply the weight 1,000-fold, and the horizon widens 1,000-fold. No curve, no complication, just a clean, straight proportion holding across every scale, from the atom size to the planet sized and beyond. Of all the relationships in nature, few are so plain. Whatever its mass, you could find a black hole's edge by the simplest arithmetic, the size following the weight as faithfully as a shadow follows its object. But the density tells the opposite story, and it is just as strange. Because a small black hole's horizon shrinks so steeply, the smallest ones are packed almost beyond comprehension. A mountain inside an atom is a density that dwarfs anything in a star or a planet. Yet the very largest black holes are, by this same measure, astonishingly thin. A supermassive giant spread across its enormous horizon can be less dense than the air you're breathing. The little ones are the densest things in existence. The great ones are wispier than a morning mist. The same kind of object at its two extremes sits at the opposite ends of everything, the most concentrated and the most diffuse, both wearing the same dark and silent face. Now the mind can widen again, because these objects touch the very largest questions too. To make primordial black holes at all, the early universe needed those density ripples to be just slightly stronger, in places, than the ripples we can measure in the oldest light. And that points back to the very first moment of all, to inflation, the breathtaking idea that the infant universe expanded faster than thought in its first fraction of a second, stretching tiny quantum tremors up to cosmic size. The pattern of those stretched tremors is what later became galaxies. But if, at some particular scale, inflation left the tremors a little stronger than elsewhere, those stronger ripples could later have collapsed into primordial black holes. Which means these objects, if found, would be a direct message from inflation itself, a fossil from the first instant of existence, telling us how the universe stretched before it had even cooled. There is a clean relationship between when a black hole formed and how heavy it could be, and it comes from a simple idea: the size of the patch that could collapse. At any moment in the early universe, there was a largest distance across which anything could yet have an effect, a horizon of cause and consequence, growing steadily as time passed and light reached further. A black hole forming at a given moment could be no heavier than all the energy contained within that horizon at that instant. So the earliest moments, with their tiny horizons, could make only the lightest black holes. Later moments, with wider horizons, could make heavier ones. The clock of the cosmos and the scale of these objects are bound together by nothing more than how far influence had spread. It is worth letting that settle, because it makes each possible mass a kind of timestamp. A black hole as light as a small asteroid would mark a moment unthinkably close to the beginning, when the horizon was smaller than a single particle. One as heavy as the sun would mark the first fraction of the first second. One as heavy as a great cluster of stars would mark a moment perhaps a few seconds in. To know the weight of a primordial black hole, then, would be to know the very instant of its making, to read, in a single number, how old the universe was on the morning it was born. So a single small black hole, drifting unseen, could in principle answer questions that span the whole of physics. What is dark matter made of? How did the universe expand at the very beginning? How did the giant black holes in galactic centres grow so fast? All of these threads run back toward the same faint ancient possibility. It is rare for one idea to touch so many of the universe's deepest secrets at once, and rarer still for that idea to be so calm a thing, not a cataclysm, but a quiet shadow, sealed away before the first light, waiting. Return now to the matter of evaporation, because there is more tenderness in it than first appears. When a black hole gives off its faint radiation, the particles that escape come in every variety the universe allows: light and the lightest particles of matter, and the ghostly neutrinos that pass through worlds as though they were mist. The exact mixture depends on the temperature, which depends on the mass, which is forever shrinking. So the glow of an evaporating black hole slowly changes its character over its enormous life, like a fire that burns through different colours as it settles toward embers. The very last moment, the final flicker, would be the hottest and the brightest of all. A brief blaze of the highest energy light, the black hole spending the last of itself in a single radiant breath. What happens at the very end is one of the open questions that physicists find most fascinating, and it is a fine thing to wonder about as the night settles. Does the black hole vanish completely, leaving nothing behind but a fading sphere of light expanding into the dark? Or does some tiny remnant remain, a last unshrinkable kernel, too small to evaporate further, a relic the size of the smallest length the universe permits? No one yet knows. It may be that the early universe left behind a scattering of such relics, each one a frozen full stop, the unevaporated heart of a black hole that has otherwise given everything away. If so, these too could be part of the dark matter, the ash of ancient fires enduring forever. A newer idea, still being explored, adds a further twist of gentleness to the ending. Some physicists have proposed that as a black hole shrinks, the great store of hidden information locked within it might act like a growing weight, a kind of inner inertia that resists the final fading, slowing the evaporation dramatically in its last stages, like a wheel that turns harder and harder to budge as it nears a stop. If this is right, then even the small primordial black holes thought to have vanished long ago might, in fact, still linger, their ending stretched out far longer than the simple reckoning suggests, a whole hidden population quietly surviving where we believed only ash remained. It would reopen a door that seemed closed and let the oldest small shadows live on after all. The lightest particles released at the end carry their own faint clue. Among the things an evaporating black hole would scatter into space are positrons, the mirror twins of the electrons that make up ordinary matter. When such a positron later meets an ordinary electron, the two annihilate in a small flash of light at one exact telltale energy. Astronomers have long noticed a soft glow of light at precisely that energy coming from the heart of our galaxy, and while there are several possible sources, a few have wondered whether some small part of it might be the distant signature of primordial black holes quietly giving up their last positrons. It is only a maybe among maybes, but it is a lovely thought that a faint and particular shade of light from the galaxy's centre might be in some small measure the afterglow of ancient shadows fading. There is a unit of weight that physicists reach for when they speak of these endings, and it carries a kind of poetry. The smallest meaningful mass in all of physics is called the Planck mass, and despite governing the tiniest scales of reality, it is not tiny at all to a human hand. It is about the weight of a small grain of dust or a single flea's egg, something just at the edge of what your eye could see. When a primordial black hole evaporates down to that last little weight, it reaches the boundary of everything physics currently understands, the place where gravity and the quantum world meet, and our equations fall silent. The end of the smallest black hole is a doorway into the one part of nature we have not yet learned to read. It is worth pausing on how completely these objects bridge the largest and smallest scales of the universe. To describe a giant primordial black hole, you need the science of the very big, the curving of space across light years, the slow turning of galaxies. To describe a tiny one in its last bright instant, you need the science of the very small, the trembling of the quantum vacuum, the briefest particles, a single kind of object asking us to hold both ends of nature in the same thought. There are not many things in all of creation that stitch the cosmic and the quantum together so seamlessly, and a primordial black hole, were one ever found, would be among the finest of them. The total number of these objects the universe might contain is, fittingly, unknown. They could be everywhere, threading through every galaxy by the trillion, the hidden backbone of all the dark matter. Or they could be exceedingly rare, a mere handful in the whole observable cosmos. Or there could be none at all, the whole idea a beautiful theorem that nature simply chose not to use. All three remain genuinely possible, and there is a rare honesty in that. Most of what astronomy studies is at least known to exist. This is a field built around an object that may turn out never to have been real, pursued with full seriousness because the universe has not yet said no. For all that uncertainty, the searches grow more sensitive each year, and the open windows narrow. Where once primordial black holes might have explained the dark matter across an enormous range of possible masses, the steady work of many telescopes has closed window after window, until only a few narrow bands remain where they could still account for all of it. The asteroid mass window is the widest of these, a band where the objects would be too small to lens visibly and too cold to glow detectably, a quiet gap in our vision in which an entire invisible universe could still be hiding. Science has not proven they are there, but it has not been able to prove they are not. And in that narrow surviving silence lives one of the most patient open questions in all of physics. Imagine, just for the comfort of it, that the asteroid mass picture is true, that the dark matter really is a sea of tiny primordial black holes, each no heavier than a mountain, each smaller than an atom. Then they would be all around you, right now, sparse but everywhere, drifting through the room, through the walls, through the earth, and through your own resting body, utterly without harm, far too small and far too fast to do anything but pass cleanly through. You would never feel one. You could not. And yet you might, in that picture, be lying in a quiet rain of the universe's oldest objects, each one a sealed fragment of the first instant, each one passing through you as gently as a thought you do not bother to hold. This is not certain. It is one possibility among several offered softly, the way all of tonight's wonders are offered. But it is a kindly thing to drift towards sleep beside. The idea that the dark is not empty, that the oldest things in existence might be all around you and entirely benign, asking nothing, taking nothing, simply present, the way the night itself is present, holding you without weight. The rate at which these objects would pass through anything depends on how thickly the galaxy is filled with them, and even at the most generous estimates, a single small black hole crossing a region the size of your body would be a once-in-many-lifetimes event, and when it happened, it would change nothing at all. Their interaction with ordinary matter is almost entirely through gravity, which is the faintest force in nature by an enormous margin. The pull between two specks is so slight that a tiny black hole would slip past every atom of you without disturbing a single one. This is the great paradox of gravity. It shapes the whole universe, holds the galaxies in their slow turning, and yet between small things it is so weak as to be almost nothing. The force that binds the cosmos barely whispers between you and a passing shadow. Think of how that compares to the other forces. The bond that holds the particles of an atom together, or the spark that leaps between a cloud and the ground in a storm, is unimaginably stronger than gravity at small scales. If you could shrink down to the size of 2 atoms, gravity between you would be so faint that whole ages of the cosmos would pass before it drew you together by even a hair's width. And yet that same threadbare force, summed over the unthinkable mass of a galaxy, is what choreographs the heavens. A primordial black hole lives entirely in that gentler register, a creature of pure gravity, communicating with the world only through the softest force there is. Some of the largest primordial black holes, were they real, might still be moving through the outer reaches of galaxies, including the great dark halo that surrounds our own. Astronomers picture the Milky Way not as the flat bright disk you see edge on in summer photographs, but as that disk wrapped inside an enormous invisible sphere of dark matter, many times wider than the stars. If heavy primordial black holes make up even a fraction of that halo, then they would be out there in the dark suburbs of the galaxy, far beyond the farthest stars, circling slowly in a region so empty and so still that a single such object might cross millions of years of silence before passing anything at all. If one were ever confirmed, it would mark something rare in human history, a kind of object known to us only through gravity, never through its light. Almost everything we have ever learned about the heavens came to us as light of one colour or another: visible, radio, infrared, the glow of distant fires. But a primordial black hole gives off no light to speak of. To find one would be to know a thing purely by its weight, by the way it bends the paths around it, as though we had reached out in the dark and felt the shape of something we could never see. A new way of knowing the universe, not by looking, but by the gentle tug of the unseen. In a sense, the search for these objects is teaching us to perceive the cosmos with a different sense entirely. For all of history, we have been creatures of the eye, reading the sky by its light. Now, with our gravitational wave detectors and our pulsar webs and our patient watching for the faint bend of passing mass, we are slowly learning to feel the universe as well as see it, to sense the weight of things that shed no light at all. Whether or not a primordial black hole is ever found, the very effort is opening a new channel between us and the dark, a way of touching what cannot be seen. There is a thought that has surfaced more than once in recent years, playful and serious at the same time, that one of these objects might be far closer than the galaxy's edge. In the distant cold beyond the known planets, astronomers have long noticed that a handful of small worlds seem to move as though tugged by something unseen, a faint, patient pull from a body that has never been spotted. The usual explanation is a distant, ordinary planet never yet found. But a few scientists have wondered, half in earnest, whether the tug could come instead from a small primordial black hole, no larger than a grapefruit yet as heavy as several Earths, drifting silently in the outer dark of our own solar system. It is almost certainly an ordinary planet if it is anything. But the mere fact that the question can be asked, that there might be an ancient black hole tucked into the far corners of our own sun's family, is a marvel in itself. If such a tiny, heavy object were truly out there at the edge of the solar system, it would be one of the strangest places imaginable. A sphere of absolute dark the size of a fruit, holding the weight of several worlds, hanging motionless in a cold so deep that the sun itself would look like just another star. No light would touch it. No instrument has seen it. It would be the quietest possible neighbour, a fragment of the first second, parked at the threshold of everything we know, keeping its ancient secret in the long shadow beyond the planets. If you could somehow draw close to one and look, which you never could and never would need to, the sight would be unlike anything else in nature. You would not see a black ball hanging in space. You would see the stars behind it smeared and bent into rings, the whole far sky warped around a small circle of perfect nothing, as though someone had pressed a clear lens into the heavens and twisted it. The darkness at the centre would not be a surface but an absence, a place where the background simply stops. Even a tiny primordial black hole would do this in miniature, gathering the light of everything behind it into a thin, bright halo around a speck of void, a flaw in the sky that is not a thing, but a shape the light is forced to take. The way these objects are described mathematically holds its own quiet wonder. To a physicist, a black hole is not really a thing made of stuff at all. It is a feature of space and time themselves, a region where the geometry is folded so steeply that all paths lead inward. A primordial black hole, then, is not so much an object that exists in the universe as a place where the universe is curved completely around on itself. When you picture one moving through the dark, you're really picturing a travelling fold in the shape of reality, not a pebble of matter, but a small, moving pucker in the fabric that everything else is written on. This is perhaps the gentlest way to hold them in the mind, not as things, but as places. A primordial black hole would not be an object lodged in space so much as a particular spot where space does something unusual, bends all the way back on itself and seals over. It carries no surface you could touch, no substance you could weigh in your hand, only a region with a special shape. And that shape, once made in the first instant, would travel onward through the ages unchanged, a small permanent crease in the smoothness of things, going quietly about its business in the dark. That fabric, the thing physicists call space-time, behaves around a black hole in ways that touch even the experience of time. Near the edge of any black hole, time itself runs slower, seen from outside, so much so that to a distant watcher, anything falling toward the horizon would appear to slow and never quite arrive, its final moment stretched across forever. A primordial black hole carries this same strange clock. At its tiny horizon, the briefest instant would, from our vantage, stretch toward eternity. Time pooling at the edge of the dark, like still water at the bottom of a well. The bending does not stop at time, it folds space as well, and in a way that has its own quiet beauty. Near a black hole, the straight paths that light and matter follow are gently curved inward, so that what looks like a straight line is really a long smooth arc bowing toward the dark. A primordial black hole moving through space would carry a small pocket of this curvature with it, a travelling dimple in the otherwise flat expanse, gathering the paths of everything nearby into the faintest inward lean. It would not grab or snatch, it would simply tilt the surrounding geometry ever so slightly, the way a heavy sleeper tilts the surface of a mattress without ever reaching out a hand. And there is a horizon to every black hole that is purely about knowledge, a boundary past which no news can ever return. Whatever crosses that edge is sealed away from the rest of the universe forever, not by walls but by the very shape of space, which bends so steeply inward that all roads lead only deeper. A primordial black hole, however tiny, would hold this same one-way threshold, a place where the universe keeps its secrets absolutely, where anything that enters becomes, from the outside, simply gone. Of all the boundaries in nature, it is the only one that's truly final, and even the smallest of these ancient shadows would carry one. Because they would be so old, primordial black holes would have witnessed, if a thing without eyes can be said to witness, the entire history of everything. A heavy one formed in the first second would have moved through the long dark age before the stars, watched the first suns ignite, seen galaxies assemble out of the gloom, felt the slow turning of 100 billion years. It would be present now, and it would still be here, almost unchanged, long after the last star has burned out and the sky has gone dark again. Of all the things the universe might contain, these would be among the few that span very nearly its whole life, from the first instant toward the last. Think of everything that would have happened around such an object while it stayed the same. Stars would have been born and died in their billions, scattering the elements that make up your body. Planets would have formed and cooled. On at least one of them, life would have stirred and grown complex and eventually opened its eyes to wonder about the dark itself. And through all of it, the ancient black hole would have simply persisted, unmoved and unchanging, the single most stable thing in a universe of ceaseless transformation, a still point around which the entire drama of cosmic history played out. It would not even need to do anything to endure. A star must constantly burn to hold itself up, and when its fuel runs out, it dies. A planet slowly cools and changes, but a heavy black hole holds its shape with no effort whatsoever, requiring no fuel, no process, no labour of any kind. It simply is, and goes on being, by the plain geometry of space. There is a deep restfulness in that, an existence that asks nothing, spends nothing, and yet outlasts everything that strives. The most effortless permanence the universe knows how to make. There is a particular comfort in the company of such long-lived things. You live a human life measured in decades, full of motion and change. But woven through the same universe, perhaps, are these ancient, almost eternal objects, formed before the first dawn and enduring past the final dusk, asking nothing, changing nothing, simply persisting in the dark. To rest beside the thought of them is to borrow for a moment a little of their stillness, the deep calm of a thing that has all the time there will ever be, and there is a stranger comfort still in being the kind of creature that can know about them at all. You're a small, soft, short-lived being, and yet your mind can reach across 14 billion years and ask what formed in the first sliver of a second. In a real sense, you're a way the universe has come to look back upon its own beginning, a small warm corner of the cosmos that has grown curious about its own first instant. The ancient shadows cannot wonder about themselves. But you can wonder about them, and in that wondering something quiet and remarkable happens. The universe, through you, contemplates its own origins. You need not do anything with that thought except let it rest on you. It asks no effort. It is simply a quiet gift, that you happen to be one of the places where the cosmos became aware enough to marvel at itself, and that tonight you can do your marvelling lying down, warm and safe, letting the great old questions turn slowly in the dark like distant lights wheeling overhead, none of them needing you to name them. The energy locked inside even a small primordial black hole is difficult to fully picture, and yet there is no menace in it from a distance. Mass and energy are two faces of the same coin, and a mountain's worth of mass holds an almost unimaginable store of energy, sealed behind the horizon, released only across the unhurried eons of evaporation. It is not a bomb. It is the opposite of sudden, a reservoir that gives itself back to the universe so slowly that the giving outlasts the stars. Only at the very end does the last small fraction emerge quickly. For nearly all of its existence, the energy simply rests there, contained, untroubling, like a deep lake that releases its water one drop at a time over an age. That equivalence of mass and energy is the same simple law that lights the stars, and it ties these objects to the most famous idea in all of science. A very little mass holds a very great deal of energy, which is why the sun can shine for billions of years by converting only a small fraction of itself to light. A black hole is the most complete expression of that idea imaginable. Pure mass, pure trapped energy, with nothing wasted and nothing burning, simply held. And over the longest spans of time, through its faint glow, it converts that held mass back into light, fulfilling the same law in the slowest and most patient way the universe allows. There is even a sense in which a black hole is the most efficient store of energy that can exist. Pack any amount of energy into the smallest space it will fit, and a horizon forms around it. You cannot concentrate energy more tightly than that without the dark closing over it. So a primordial black hole represents a kind of ultimate limit, the densest that anything in the universe is permitted to be. To imagine one is to imagine the very edge of what nature will allow before it draws a curtain and folds the space away. And yet, for all that extremity, from any distance it would sit perfectly still and silent, harming nothing, a maximum hidden inside a calm. It helps to remember that the universe is overwhelmingly made of such quiet things. The bright stars and glowing galaxies that fill our pictures of space are a thin sprinkle of light across an enormous, dark, calm vastness. Most of the cosmos is empty, cold, and still. If primordial black holes are part of it, they belong to that silent majority, not to the rare flares and explosions, but to the deep, untroubled dark that makes up nearly all of space and time. The universe is, at heart, a restful place, and these objects would be among its restful citizens. The conditions needed to make them have been studied with great care, and they turn out to be exquisitely particular. The early density ripples had to be strong enough to collapse, but not so strong as to disturb the universe we actually observe. This is why, if primordial black holes exist, they are probably rare. The recipe is delicate, and the universe seems to have followed it sparingly, if at all. There is a kind of restraint in that, as though the cosmos sketched the possibility lightly and then mostly left it alone, the way a careful hand leaves most of a page blank. Different theories of the very early universe predict very different numbers of these objects, and so the search for them is also a search for the truth about the beginning. If many are found, certain ideas about inflation in the first instant would be favoured. If none are ever found, others would be. In this way, the empty-handed searches of the past decades have not been failures at all. Each one has quietly told us something true about how the universe began, narrowing the possibilities, sharpening the picture. Absence, carefully measured, is a form of knowledge. There is a striking possibility too that the early universe might once have belonged to these objects entirely. If enough of the small ones formed, then for a stretch of the first moments their combined mass could have outweighed everything else, all the light and heat and ordinary matter put together, so that the young cosmos was, briefly, a universe ruled by black holes. Then, as the small ones evaporated away, they would have flooded everything with fresh radiation, handing the universe back to light and resetting the stage for all that followed. A whole hidden chapter, perhaps, in which the dark briefly held the lead before dissolving itself and returning the cosmos to brightness. We may be the heirs of an age we can never see. If that chapter happened, it would have left the gentlest of fingerprints, a particular pattern in the relic light, a certain texture in the oldest signals that careful instruments might one day read. So even an era that ended before the first second was fully spent, an era of pure darkness ruling a newborn universe, is not entirely beyond our reach. It is a humbling and soothing thought that the cosmos may have passed through a phase belonging wholly to the very objects we are now trying to find, and then quietly erase nearly every trace, keeping only the faintest whisper for us to puzzle over in the long after. The smallest black holes that could still survive today sit at a fascinating threshold. Just below a certain mass, around that of a large mountain or a small asteroid, a primordial black hole would already have finished evaporating, vanished long ago in a last burst of light. Just above it, the black hole would still be here, glowing too faintly to detect, drifting on toward an end still trillions of years away. So there is a sharp line in mass that divides the survivors from the long departed, a kind of tide mark left by the passage of cosmic time. Everything lighter is already gone, everything heavier remains, and right at the line, a few may be flickering out in this very era. This means that the population of primordial black holes the universe holds today, if any, has been gently filtered by time itself. The lightest born have all expired, only the heavier ones endure. So whatever is out there now is, in a sense, a survivor, the enduring remainder of a much larger original family, most of whose members faded back into light long before the Earth was formed. To find one today would be to meet an elder, one of the few that were born heavy enough to outlast nearly the entire history of the cosmos. There is a tenderness in that idea of a thinning family. Picture the original crowd, born in the first instant in every size the universe allowed, a vast spread of shadows, from the featherweight to the colossal, and then picture time passing, and the lightest of them giving up their light and vanishing one after another, the smallest first, in an order set entirely by their weight. What remains today would be only the heavier survivors, the patient ones, spaced out across the dark like the last few notes still sounding from a chord struck long ago. Everything quicker has already fallen silent. Only the slow, deep tones remain, and the very heaviest would still have almost all of their existence ahead of them. A black hole as weighty as a star, or a galaxy's giant heart, has barely begun to fade. Its life so long that the entire age of the universe so far is only the first faint moment of it. These great ones are not survivors of a long ordeal so much as newborns who have scarcely started, with timescales stretching ahead so vast that the death of the last star will come and go while they remain almost untouched. To them, this whole bright era of stars and galaxies is a brief opening flicker in a life that has hardly begun. Astronomers sometimes speak of the diffuse glow of high-energy light that fills the whole sky, a faint uniform background of gamma rays coming from no single direction, the summed light of countless distant sources. If primordial black holes of certain masses were common, their steady evaporation would add a particular signature to that background glow, a specific shape in the spread of energies. By measuring the background with great precision and finding no such signature, astronomers have placed yet another limit on these objects. The very faintest light in the sky, the gentlest possible glow, becomes a ruler for measuring the unseen. Even the background hum of the cosmos is being read for their fingerprints. There is a beautiful patience required to do this kind of science, and it mirrors something in the act of falling asleep. You cannot force a discovery any more than you can force rest. You prepare the instruments, you watch the sky, you wait, and you let the universe reveal itself in its own time, or not at all. The astronomers who hunt for primordial black holes have learned to hold their question lightly across whole careers, content to add one more careful measurement to the slow accumulation of human knowledge. There is no rushing it. There is only the steady, attentive waiting, and a deep trust that the looking itself is worthwhile. Consider, as the night deepens, just how thin the line is between something and nothing in this story. A density ripple in the early universe that was a hair too weak would have rocked harmlessly and faded, leaving no black hole at all. A hair too strong, and far too many would have formed, reshaping the whole cosmos into something we would not recognize. The universe we live in sits in the narrow space between those extremes, a place where primordial black holes are possible but not abundant, allowed but not required. We exist in the gentle margin, and so might they, neither forbidden nor guaranteed, hovering in the soft maybe between. That same delicate balance runs all through the story of why anything exists as it does. Had the early ripples been much larger everywhere, the universe would have been choked with black holes, with little room for stars or planets, or the long, calm stretches of space in which life could one day appear. Had they been much smaller, nothing would ever have gathered into galaxies at all. The gentle particular strength they actually had is part of what made a livable cosmos possible, and primordial black holes, formed only where a rare ripple crested highest, are a kind of marker of just how finely that balance was struck. They live at the very tail of what the early universe allowed, the rare exceptions to its overwhelming smoothness. It is a strange thing to find comfort in, and yet there is comfort there. The universe did not have to be this gentle. It could have been violent, crowded, restless, a place of constant collapse. Instead, it settled into something mostly calm and mostly empty, with its rare dark folds scattered thin across enormous quiet distances. The very rarity of these objects is a sign of how peaceful the cosmos turned out to be, and you are a small living part of that peace, lying here in the stillness it made room for. The shapes these objects could take in the imagination are endless, and all of them are forms of dark. A point smaller than an atom holding a mountain, a sphere the size of a fruit holding several Earths, a giant in a galaxy's heart, millions of suns folded into a region a light day wide, each one a different scale of the same essential thing, a place where matter or energy has gathered so densely that it has wrapped space shut around itself. From the tiniest to the most enormous, they are all the same gesture of the universe, a folding inward, a sealing away, a small region choosing to become a door that only opens one way. It is worth knowing that you do not even need matter to make one, because energy and mass are the same thing. A sufficiently intense concentration of pure light, squeezed tightly enough, would itself bend space shut and form a black hole, a sphere of darkness born from nothing but radiance. In the blazing first instant, when the universe was almost entirely light and heat, this is close to how the primordial ones would have formed. Not from rock or gas, but from the sheer density of energy in the newborn cosmos. A shadow made of light. There is a quiet poetry in that the darkest objects the universe could hold might have been forged from its first and brightest fire. And once formed, by whatever means, each would be utterly alike in their essential nature, differing only in scale. There are not many kinds of black hole, the way there are many kinds of star or planet or moon. There is, in a deep sense, only one kind of thing, appearing at different sizes, a single, simple form repeated across an enormous range, like the same note played at every pitch. From the atom small to the galaxy vast, the same flawless geometry, the same one-way edge, the same perfect dark. A theme with countless variations, all of them quiet, all of them the same at heart. It is worth saying, plainly and reassuringly, that none of this is a danger to you or to the Earth. The primordial black holes that might still exist are either far too small to do anything but pass harmlessly through matter, or far too distant to ever approach. There is no scenario in serious science where one of these objects poses any threat to your life or your world. They are a wonder, not a worry, a quiet feature of the deep cosmos, as remote from your safety as the light of a distant star. You can rest entirely at ease with them in your mind. They have been around, if at all, for the whole life of the universe, and have left the Earth utterly untouched. The more you sit with the idea, the more it begins to feel less like a fearsome thing, and more like a kind of cosmic punctuation. Small dark marks scattered through the long sentence of the universe, each one a place where the page folds in on itself for a moment. The bright matter, the stars and galaxies, is the text. These would be the pauses, the held breaths, the places where the page goes still, and like the silences in music, they would be part of the beauty, not a flaw in it. A universe with such folds in it is a richer thing than one without. Music, in fact, is not a bad way to hold the whole of it. The cosmos is full of sound that no ear was ever built to catch, and shapes that no eye will ever see. The deep, slow stretching of space as the great waves roll through, the long ringing of merging giants far across the dark, the faint sky-wide hum that may carry the very first instant folded somewhere within it. Across all of that, the ancient shadows would be the lowest notes, the deepest tones beneath the melody, felt more than heard, holding the whole composition steady from below. There is a piece playing that no ear can hear, and you can simply let its lowest, oldest notes carry you down into rest. There is a question that physicists return to about whether information can ever truly be lost inside a black hole, and it touches these primordial objects too. When something falls in, all its particular detail seems to vanish behind the horizon, and when the black hole later evaporates away to nothing, it is not at all clear where that detail goes. This is one of the great unsolved puzzles of physics, and a primordial black hole, born simple and evaporating completely, is one of the cleanest places to ask it. The answer, when it comes, may reshape our understanding of reality itself, and it may come in part from contemplating the very oldest and smallest of these shadows. A hot, shrinking primordial black hole would also be one of the strangest laboratories imaginable. Because its glow grows hotter as it shrinks, in its final stages it would begin to give off every kind of particle there is, including perhaps kinds we have never yet seen, particles too heavy to make in any machine on Earth. The evaporation would not pick and choose, it would produce whatever the universe permits, in proportion to the rising heat. So the death of a tiny black hole could be a doorway onto undiscovered physics, scattering into space the rarest constituents of nature, things no laboratory has ever held. To watch one end might be to glimpse for an instant particles from the very edges of what can exist. It is a wonderful inversion to sit with. We build enormous machines, kilometers around, to accelerate particles to tremendous energies and catch the rare things that emerge. But a single small primordial black hole, in its dying moment, would reach energies beyond anything we can engineer, achieving for free what our greatest instruments strain toward. The universe, in the quiet death of one ancient shadow, would briefly outdo every laboratory humankind has ever built, and ask nothing in return but that someone happened to be watching the right patch of sky. You do not need to resolve any of that tonight. The puzzles can wait. They have waited for decades and will wait gladly a little longer. It is enough to know that somewhere, brilliant and careful minds are turning these questions slowly in the light, and that the universe is under no obligation to answer quickly. The not knowing is comfortable here. It is a place to rest, not a problem to solve. In the grand timeline of the cosmos, primordial black holes belong to the very first chapter, written before almost everything else. Before the first star, before the first galaxy, before the first atom even, in the opening fraction of the opening second, the conditions were set that might have made them. They are, in a sense, the universe's firstborn, if the universe gave birth to them at all. And like all firstborn things, they would carry the marks of a time no later thing can remember, a moment so early that the universe itself was still deciding what it would become. Think of how much had not yet happened when they would have formed. The atoms that fill your body, the iron in your blood, the calcium in your bones, had not been forged. They would be cooked, much later, in the hearts of stars that did not yet exist. There was no hydrogen gas, no helium, none of the simple matter that everything is built from. There was only a smooth ocean of light and heat, expanding and cooling, and within it the faint ripples that might here and there fold shut into shadow. To have formed in such a place is to have come before nearly the entire inventory of the universe, to be older than the very atoms. It is the kind of antiquity that puts the mind at ease rather than straining it. There is nothing to fear in something so old. It has had every chance to do harm and has done none, drifting silently through age after age, indifferent and unchanging. The oldest things tend to be the calmest, having outlived every storm, and these would be among the very oldest of all, survivors of a time before time had much shape, carrying their stillness forward into a universe that grew up around them, asking nothing, disturbing nothing, simply enduring in the deep dark. It is humbling and soothing at once to consider that everything you have ever known, every star you have seen, every person you have loved, the very atoms of your resting body, came after these objects might have formed. They would predate it all. The matter that became you was still a formless heat when the first primordial black holes, if any, sealed themselves shut. You are, in that sense, a very late arrival to a very old universe, and there is rest in being late. Rest in knowing the great old structures were here long before you, and will remain long after, holding the shape of things while you sleep. sit too with the sheer reach of the timescales here, because there is comfort in their enormity. The lightest of these objects would have lived and died before the universe was a single second old. The heaviest would outlast the stars by spans so long that to write the number, you would need more zeros than there are atoms in a room. Between those extremes lies every length of existence imaginable, and your own life, your handful of decades, is a brief warm spark somewhere in the unimaginable middle, not lessened by the vastness around it, but cradled by it, a small bright moment held safe inside something immeasurably old and unhurried. It can steady the heart to remember how much endures beyond us, whatever troubles the day may have held, whatever the mind was turning over before it began to soften towards sleep. The great old framework of the cosmos goes on unbothered, exactly as it has for billions of years. The ancient shadows, if they are there, keep their shape. The galaxies keep their slow turning. Nothing you carry tonight touches any of it, and there is a strange relief in that smallness, to be a brief, warm, living thing, set down gently inside a universe far too vast and far too old to be disturbed by anything you need to let go of now. The faint glow these objects emit, the Hawking radiation, is so feeble for any large one that it has never been measured for any black hole at all. Not the giant in our galaxy's heart, not any of the stellar ones. It remains a prediction, beautiful and almost universally believed by physicists, yet still waiting for its first direct confirmation. A primordial black hole reaching the end of its life, winking out in a burst we could finally catch, might be the very thing that confirms the glow is real. So these oldest objects could, in their dying, prove one of the deepest predictions about the nature of black holes. The first to be seen evaporating might also be the first proof that evaporation happens at all. This is part of why the search matters so much to physicists, beyond the question of dark matter. The idea that black holes glow and slowly fade sits at the very crossing point of the two great pillars of modern physics, the science of gravity and the science of the very small, and those two pillars have never been fully reconciled. To catch a primordial black hole in the act of evaporating would be the first real glimpse of the place where they meet. It would be a thread leading toward the deepest theory we do not yet have, an ancient shadow in its dying breath, lighting the way toward the unified understanding that physics has sought for a century. There is something fitting in the thought that the oldest objects might illuminate the newest physics. The very things born first, in the opening instant before any law had fully settled, would be the ones to show us how the deepest laws fit together. The beginning, reaching forward across all of time to teach us about the foundations. It is the kind of circle the universe seems fond of drawing, the end of one of its first creations becoming the doorway to our final understanding. There is a tenderness in imagining that final confirmation, a single flash from the deep dark, after a 14 billion year wait, telling us at last that Hawking was right, that black holes do breathe out their being into light, that nothing in the universe is entirely permanent, not even the darkest traps. It would be a small flicker on an instrument, easy to miss, and it would carry the weight of a profound truth, that all things given long enough return to light. Even the deepest dark in the end gives itself back to the glow. Let that idea rest on you like a warm hand. Nothing is permanent, and yet the impermanence is so unhurried, so vast in its patience, that it feels like permanence from any human view. The black holes outlast the stars, the remnants may outlast the black holes. And through it all, the universe keeps gently transforming one thing into another, light into matter, into shadow, and back into light, in no hurry at all, across timescales beside which a human life is a single quiet breath. The very concept of a primordial black hole rests on trusting our deepest physics far past the places we can test it, into the first second, into the smallest scales, into densities no laboratory will ever reach. That such an idea can be reasoned about at all, that mathematics can reach into the universe's first instant and bring back a clear picture of what might have formed there, is itself a quiet marvel. The human mind lying in the dark, reaching backward across 14 billion years to a fraction of a second it can never visit, and finding there a coherent, beautiful possibility. There is wonder simply in the reaching, that thought alone can travel where nothing else ever will. It is striking how much of modern cosmology has been shaped by simply taking these objects seriously, whether or not they exist. The effort to rule them in or out has sharpened our maps of dark matter, refined our reading of the oldest light, and driven the building of ever more delicate instruments. An idea need not be confirmed to be fruitful. Sometimes a beautiful maybe pulls a whole field forward by the simple force of being worth checking. Primordial black holes have been one of those generous maybes, giving much to science while asking only to be looked for. It is a lovely turn of history that the very glow which would betray these objects was first worked out by a young physicist thinking about them. When Stephen Hawking set out to understand the smallest black holes the early universe might have made, he found, to his own astonishment, that they could not be perfectly black at all, that they must leak energy and slowly fade. The discovery that black holes glow, one of the most celebrated results in all of science, grew in part from wondering about these tiny primordial shadows. They have been quietly generous from the very beginning, giving us a profound truth about all black holes simply by being imagined. The space around us keeps its own ledger of them as well. From every direction, faint streams of high-energy particles drift through the galaxy. Cosmic rays, the scattered debris of distant violent events, including a small trickle of antimatter among them. If many small primordial black holes were evaporating nearby, their escaping particles would swell that trickle in a particular way. Astronomers measure these faint streams with instruments flown high above the atmosphere and even mounted on the orbiting station that circles the Earth, and the gentle quantities they find place yet another soft limit on the unseen. Even the thin rain of particles passing through the solar system, read with enough care, becomes a way of listening for the oldest shadows. As the searches continue into the years ahead, new instruments are being readied that will peer into the few remaining windows with unprecedented care. Space-based detectors of gravitational waves spanning millions of miles, sharper gamma-ray telescopes, vast surveys that will watch billions of stars at once for the faintest brightening of lensing. It may be that within your lifetime one of these will either find a primordial black hole or close the last window where one could hide. Either answer would be a triumph. To find one would rewrite the story of the dark matter in the beginning. To rule them out entirely would be its own hard-won clarity. The question is approaching an answer, slowly, the way dawn approaches without your watching. One of those future instruments would be a trio of spacecraft flying in formation across the emptiness, trailing the Earth around the Sun, holding a perfect triangle between them by tracking faint beams of laser light. As a long gravitational wave rolled through, the distances between them would shift by less than the width of an atom, and they would feel it. Such an instrument could hear the deep, slow ripples that heavier black holes make, and listen too for any faint hum left over from the first instant. 3 small craft drifting in the dark between the worlds, straining together to hear the softest echoes of the beginning. It is the kind of thing that could only be built by a species that had fallen in love with patient questions. Whatever those instruments find or fail to find, the looking itself will go on. There will always be a few careful people turning their gaze toward the deepest dark, asking what formed there in the first sliver of time. It is one of the quietly hopeful things about our kind, that we keep asking across generations questions we may not live to see answered, content to add our small part and pass the rest along. The search for these ancient shadows is one long conversation, carried forward in the dark by people who simply wish to know. But tonight the question is still open, and there is a sweetness in resting inside an open question in the brief era before it closes. For now, the universe keeps its secret. For now, somewhere in the deep dark there might be a mountain folded into an atom, or a fruit-sized sphere as heavy as worlds, or a giant seed at the heart of a galaxy, or there might be none of these at all. You get to lie here in the not yet knowing, in the gentle suspension of a mystery still unsolved, and let it rock you towards sleep like a question whispered and left hanging in the dark. Far from any of this searching and wondering, the simple physical reality remains serenely indifferent and calm. If primordial black holes exist, they are out there right now, doing nothing dramatic at all, moving without haste, evaporating with infinite slowness, bending the occasional ray of starlight, keeping the shape that the first instant gave them. They do not know they are being looked for. They do not know they are mysterious. They simply are what they are, ancient and dark and still, and they would go on being exactly that whether or not a single human ever confirmed them. There is a freedom in objects like that, a freedom you can borrow for the night. They carry no burden of being understood. They do not wait anxiously for their discovery, or worry whether the searches will succeed. They have no tomorrow to dread and no yesterday to regret. They simply exist, fully and completely, in whatever moment they are in, the same as they have been since the beginning. To picture them is to be reminded that existence need not be effortful, that a thing can simply be, without striving, and that this is enough. You can let yourself be a little more like that as you settle. You do not have to solve anything before you sleep. You do not have to hold the day together, or carry tomorrow ahead of time. Like the ancient shadows, you're allowed to simply be here, now, exactly as you are, asking nothing of yourself, with nothing to prove and nowhere else to be. The universe has held its great unanswered questions for billions of years without distress. You can let yours wait until morning. There is deep rest in that indifference, the same rest you can feel looking at a mountain or the sea, the calm of something vast that does not need you, that was here before you and will be hereafter, that holds its shape without effort or worry. The oldest possible objects in the universe would carry that quality to its furthest extreme, a stillness 14 billion years deep, an unbroken calm older than light, a silence that has never once been troubled by a single anxious thought. To rest your mind against that silence is to let some of it soak into you, here in the dark, as your breathing lengthens and your body sinks a little further into the warmth of the bed. You can let your thoughts move at that same unhurried pace now. There is no answer you need to reach tonight, no window of the sky you must keep watch over. The astronomers will keep watching for you, across the years, on their dark mountain tops. The instruments will go on listening, and the slow accumulation of human knowledge will continue, with or without your attention, gathering one careful measurement at a time, the way a shoreline gathers its shape from the sea over ages. You're allowed now to set all of it down. So let the searching telescopes fade from your mind, and the equations and the windows still open or closing. Let the numbers grow soft and slip away. Keep only the simplest image, a small, ancient, harmless dark, sealed at the beginning of everything, drifting somewhere far away, or perhaps passing through you this very moment without a trace, as gentle as the dark in the room around you. It asks nothing. It means no harm. It has been resting far longer than you have, and it is content to rest a little longer still. And here is the last and quietest wonder of all, the one to carry with you over the edge of sleep. In the very same fraction of a second that might have sealed these black holes into being, the universe also set in motion everything that would lead, across 14 billion patient years, to you, to this body, this breath, this still and resting mind in the dark. The same first instant that may have folded a mountain into an atom also began the long unbroken chain that became the warmth of your blood and the slow rhythm of your breathing tonight. Whatever primordial black holes are, or whether they are anything at all, they are your kin in this one true way. You and they, if they exist, are both children of that single opening moment, both made of the first instant, both still here, drifting through the same enormous and gentle dark. And so the two of you would share a beginning. The oldest, darkest, most distant objects the universe could hold, and you, soft and warm and alive, sinking now towards sleep, woven from the same first light, set going in the same first breath of time. There is no distance across all the billions of years and miles that can undo that quiet kinship. You belong to the same beginning. You're made of the same dawn. Everything between you and them is only difference of form. The same energy that might have folded itself into a sphere of shadow at the dawn of time went, by another long road, into the slow making of a living, breathing being who could one day lie in the dark and think about it all. One path led to stillness and dark. Another led, across 14 billion years, to warmth and breath and wondering. But the source was one. The first instant held both of you, undivided, before either had taken any shape at all. There is a deep peace in feeling how small the distance really is between yourself and the most ancient things in existence. You tend to imagine the cosmos as something far away and other, vast and cold and separate from your small, warm life. But you're not separate from it. You're made of it, born of the same beginning, kin to its oldest shadows and its brightest stars alike. Lying here in the dark, you're not a stranger looking out at the universe. You are the universe, resting for a while in the shape of a person, letting itself grow quiet for the night. You have wandered now to the far edge of the night, all the way to the universe's first instant and back, and there is nothing left to reach for. The journey is complete. Every wonder has been offered, and you needed to hold on to none of them. And if you are still here, drifting just above sleep, another quiet journey is already waiting for you on the screen whenever you want it, ready to carry you further into the calm or to wait there in silence as long as you like. There is no need to choose it now. There is no need to choose anything now. Let the facts go. Let the numbers and the names dissolve. You do not have to remember a single thing. The mountains folded into atoms, the seeds at the hearts of galaxies, the faint blue shimmer on the mountaintops. Let them all settle into the dark and rest there without you. They will keep. They have kept for 14 billion years. They can keep through the night. Feel how heavy your body has become. Feel the bed beneath you holding all of your weight so that you no longer need to hold any of it yourself. Your breathing has slowed on its own. Your thoughts have grown spacious and few. There is nothing to do now, nowhere to be, no window to watch, no flicker to catch, no question to answer. Only the dark and the warmth and the slow tide of your breath. The oldest things in the universe are resting somewhere far away, and you are resting here. Let the night hold you the way space holds its quiet shadows, gently, completely, asking nothing in return. Softer now, slower now, and now 101 wonders are resting with you. Sleep now. Good night.